These are the solutions for Calc 2 Exam 5. Okay, number 1, we know it's alternating, starting with a negative. So that's going to be a negative 1 to the nth power. 1, 3, 5, 7, that's going to be 2n minus 1. So a sub n is negative 1 to the n over 2n minus 1. Number 2, treat it as 0.63 plus 0.0063 and so on. So S is A over 1 minus R. So the first term would be 0.63. The common ratio is 0.01. So 1 minus 0.01 is 0.99. That's 63 over 99 or 7 over 11. Number 3, integral from 1 to infinity of 1 over radical x to the 5th dx by using the integral test. So limit as b approaches infinity of the integral from 1 to b of x to the negative 5 halves dx. So limit as b approaches infinity of x to the negative 3 halves divided by negative 3 halves means times negative 2/3 from 1 to b. Factor out the negative 2/3. Limit as b approaches infinity of 1 over x to the 3 halves from 1 to b, which is negative 2/3. Plug in. So limit b approaches infinity of 1 over b to the 3 halves minus 1. When b gets big, this approaches 0. So I have negative 2/3 times negative 1, which is 2/3. So since the integral converges, so does the series converge by the integral test. Number 4, this looks like 1 over n to the 2/3. So I'll compare it to summation 1 over cube root of n squared, or summation 1 over n to the 2/3. So limit comparison test says take the ratio of this to this and take the limit as n approaches infinity. Okay. So limit of 1 over cube root of n squared plus 1 over 1 over cube root of n squared. Going back up. Okay. I decide to multiply top and bottom by cube root of n squared, which means this is now gone, and put it on under 1. So square root of n squared, this should be cube root. There's a cube root here. So cube root of n squared plus 1, divide top and bottom by n squared. So you have the cube root of 1 over 1 plus 1 over n squared. So when n gets big, this is the cube root of 1, which is 1. And what happens to summation of 1 over cube root of n squared? That's summation of 1 over n to the 2/3. That diverges because it's a p series with p equal to 2/3, which is less than 1. Therefore, the original series also diverges by the limit comparison test. Okay, 5 is your basic example of AST, alternating series test. All right, so it's alternating, terms decrease in absolute value and approach 0. Therefore, the series converges by alternating series test. Number 6, best way to do situations with the factorial is with the ratio test. So absolute value of summation of an plus 1 over an. When you're doing absolute value, you can change negative to 1,000 to just positive 1,000. So 1,000 to the n plus 1 over n plus 1 factorial times n factorial over 1,000. The 1,000 stuff gives you 1,000 on top. The factorial is given n plus 1 on the bottom. So that approaches 0 as n approaches infinity. Therefore, the series is absolutely convergent by the ratio test. 7, also do the ratio test. Absolute value of a sub n plus 1 over a sub n is 2 to the n plus 1, x minus 3 to the n plus 1 over square root of n plus 1 times the flip of the original, so radical n on top, 2 to the n, x minus 3 to the n on the bottom. So let's see, put together the radical n over n plus 1, so we know that approaches 1 as n goes infinity. The 2 stuff gives me a 2, and the x minus 3 stuff gives me an x minus 3. So this approaches absolute value of 2 times x minus 3 as n approaches infinity. Right, so when will this converge? When absolute value of 2 times x minus 3 is less than 1, which means 2 times x minus 3 is between negative 1 and 1. Divide by 2, negative 1/2, less than x minus 3, less than a half, add 3. So 2.5 less than x, less than 3.5. So my radius of convergence is 0.5. We already knew from the get-go that the series was centered at x equals 3. Half a unit that way, half a unit that way, which means r is 0.5. So in between, I have absolute convergence. Here and here, I have divergence. And a 2.5 and a 3.5, we don't know. We have to plug in separately. Quick double check. If I plug in 2.5, 2.5 minus 3 is negative 1/2. Times 2 is negative 1, whose absolute value is 1. Therefore, the ratio test is inconclusive. Likewise, if I plug in 3.5, 3.5 minus 3 is 0.5, times 2 is 1, absolute value of 1 is 1. So once again, the ratio test fails. So I just plug in. So plug in 2.5 to the original. So plug in 2.5 to the beginning. 2.5 here, that will give me negative a half to the n, times 2 to the n is negative 1. So you have negative 1 to the n over radical n. That converges by the alternating series test. So color that in. But I would plug in 3.5. 3.5 minus 3 is 0.5. 2 to the n times 0.5 to the n is 1 to the n. 1 to the n is just 1. So I have summation of 1 over radical n that diverges because it's a p series where p is equal to half, which is less than 1. So my interval of convergence is going to be bracket 2.5 comma 3.5 parenthesis. So I is bracket 2.5 comma 3.3 parentheses, and the radius of convergence is 0.5. Okay, number 8 to 6 decimal places, 1 over 1 minus a minus x to the 7th. So that's a, that's 1 minus r. So the first term is 1, then I keep multiplying by negative x to the 7th. So minus x to the 7th plus x to the 14th minus x to the 21, dot, dot, dot. So x minus x to the 8th over 8 plus x to the 15 over 15 minus x to the 22 over 22. Plug in 0, it's all 0. Plug in 0.1. So 0.1 minus 0.1 to the 8th over 8 plus 0.1 to the 15th over 15, and so on. It's alternating. Terms decrease in absolute value and approaches 0. So this series converges by the alternating series test. By the alternating series estimation theorem, if we stop anywhere, the error is no more than the next term. Well, they want an accuracy to 6 decimal places. This is already less than 10 to the minus 8, actually, because the top is 10 to the minus 8, and if you divide by 8, it's only going to get smaller. So I only need the first term. So there it is, 0.10000, since it says the 6 decimal places. Okay, number 9. So I use the fact that cosine x is x to the 0 over 0 factorial minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial plus x to the 8th over 8 factorial. So 2x means put 2x there, 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 there. 1 minus the whole thing is 1 minus parentheses, all of that. The 1's cancel out, and then you're left with changing all of these signs. So 4x squared over 2 plus 16 x to the 4th over 24 minus 64 x to the 6th over 720 plus 256 over 40,320 x to the 8th, and so on. Okay, and then I just divide by 2. So if I divide by 2, I get this. So x squared plus 1/3 x to the 4th minus 45 over 2 x to the 6th plus 315 x to the 8th plus dot, dot, dot. Finding number 10. Find a Taylor polynomial which approximates tangent of x to degree 3. So I need 3 derivatives. So f prime is secant squared. F double prime is 2 secant x times secant x tangent x, which is 2 secant squared x tangent x. Third derivative, I have to use the product rule. That's the first function. Second function, so 2 secant squared x times derivative of tangent x, which is secant squared x, plus tangent x times, I'm just putting 2 secant squared x prime, because I know I'm going to be plugging in 0, and when I plug in 0, this all comes out to be 0. So I don't even have to figure out what this is. Tangent of 0 is 0, secant of 0 is 1. So f of 0 is 0. F prime of 0, put a 0 there, secant 0 is 1, square root is 1. Okay, f double prime is 0 because when I put a 0 here, that whole thing is 0. F triple prime, again, I didn't bother figuring this because when I plug in for 0, that's going to be 0. So put a 0 here and a 0 here. I get secant squared of 0 is 1. Another secant squared of 0 is 1. So f triple prime is 2. So T3 is 0, x to the 0 over 0 factorial, plus 1, x to the 1 over 1 factorial, plus 0, x squared over 2 factorial, plus 2, x cubed over 3 factorial. That's gone, that's gone. So final answer is x plus 1/3 x cubed. Right, so that was exam 5 for Math 110.